Welcome back, everybody. This is a teaching video for sample problem 7.12 on the determination of a molecular formula from the empirical formula. So, if you were trying to find the empirical formula, you want to know the amount of moles in comparison, the relationship of the amount of moles of each of the component elements in a compound. To do that, you start normally with a percentage. So in this example, they give you melamine, it's a plastic, is going to contain a certain amount of carbon, hydrogen, and nitrogen. So I'm going to start that here. So it says we have 28.57% carbon, 4.80% hydrogen, and 66.64% nitrogen. Now, this is a percentage of any amount. So this could be like 28% of a ton or 28% of a pound. If I could choose something based in 100, it would make my numbers very easy because 28% of 100 is 28. Okay, so my numbers would not change, and it just basically saves me a step. So I'm going to assume a 100-gram sample of this melamine. And since I'm doing that, 28.57% of 100 is 28.57 grams of carbon. Likewise, 4.80 grams of hydrogen and 66.64 grams of nitrogen. Now, each one of these elements weigh a different amount. So 4.8 grams of hydrogen is very little, whereas 28 grams of carbon might be more. So there's no real way to compare one element to another since they all have different masses. The way to do this is to put it into moles. Once you are in moles, all of them are based upon the same amount of molecules, the same amount of atoms. 1 mole of atoms is equal to a certain number of atoms. So you are actually comparing the same amounts, like a dozen, or in this case a mole. So I'm going to turn 28.57 grams of carbon into moles of carbon. And I do that by going through the periodic table. And the atomic mass of carbon is 12. So there are 12 grams of carbon in 1 mole of carbon. There is in 1 mole of hydrogen, there is 1 gram of hydrogen. This is all from the periodic table. And in 1 mole of nitrogen, there is 14 grams of nitrogen. Okay, so this is going to be a conversion factor that I can multiply by the amount that I have to turn it into moles. Once it's in moles, I can compare them and find out what the formula would be. So I've got here 28.57 grams divided by 12, and that gives me 2.38 moles of carbon. 4.8 divided by 1 is 4.8 moles of hydrogen. That's always the easy one. And 66.64 divided by 14 is 4.76 moles of nitrogen. Okay. Now, I could say carbon with a carbon 2.38 as a subscript and hydrogen 4.8, but it wouldn't mean anything. I only understand formulas when I have whole numbers, little integers telling me I've got 2 hydrogens and 1 oxygen, something like that. I don't understand what 4.76 hydrogens mean. You can't have 0.76 of a hydrogen without blowing up a town. So what I'm going to do is find the relationship between these things, and the way I'm going to do it is to take the smallest number of moles, in this case the smallest number of moles is 2.38, and divide it into each one. So essentially I'm comparing everything to carbon or hydrogen or nitrogen. So the smallest number of moles here is carbon. So if I divide carbon by 2.38, I get a beautiful number 1, very easy. If I divide 4.8 moles by 2.38 moles, 4.8 divided by 2.38, I get 2.01. Okay. Now that's the same as 2. That's very, very close. I can do a little bit of cheating, and so that's essentially 2. So I'm just going to ignore that 0.01. If I take 4.76 and divide by 2.38, try that again, 4.76 divided by 2.38. Oh, I was right. It's a direct 2. That's nice. Okay. So I've got 1 to 2 to 2. Now the 1 was carbon. So I've got carbon, and I don't have to put a 1. You don't need a 1 subscript. You just leave it as C. H is next, and it's 2. And the next one is nitrogen, and nitrogen is also 2. This is called the empirical formula. The empirical formula. And the empirical formula is not the formula of the molecule, the way that melamine actually exists, but it's the smallest ratio of elements within melamine. In order to find out if the empirical formula is exactly the molecular formula, and that's what I was asked, if the molar mass is 126 grams for melamine, what is the molecular formula of melamine? Well, this is not the molecular formula necessarily. I have to check it to see if it is, and the way I do this is, first of all, ask myself, what does this weigh? What is the molar mass of this molecule? And then compare it to 126. So in this molecule, I've got 1 carbon atom at 12. I've got 2 hydrogen atoms at 1 each. And I've got 2 nitrogen atoms at 14 each. Okay. So 28 plus 2 is 30, 40, 42. This is 42 grams per mole. This compound here is 42 grams per mole. Now, I was given that the molar mass of melamine is 126 grams, okay, per mole. Okay, so I need to compare these two. In what way are they related? Well, I'm hoping that this is a multiple of 42. Okay, and I find that out simply by dividing it. So I'm going to start with 126 divided by 42, and I want a whole number if I can get it. And I do. So we're going to see that melamine is 3 times this for each of the elements. Each of the elements is 3 times this. It's a multiple of this. So it's 3 times 1, 3 times 2, 3 times 2. Well, if I do that, 3 times 1 is 3. 3 times 2 is 6. And 3 times 2 is 6. This is the molecular formula of melamine. Okay. I hope this helps you. Watch it as many times as you need, and see me in class.